Hello everyone, I am Preeti Rajasallapur, fourth sem CSE student of Sri Venkateswara College of Engineering. Today I am going to represent upon a topic concurrency control in database. Introduction to concurrency control in databases. Concurrency control is a crucial aspect of database management that ensures multiple users can access and manipulate data simultaneously. It aims to maintain data consistency, prevent conflicts, and ensure transactions are executed correctly. Without proper concurrency control, issues such as lost updates, dirty reads, and inconsistent data can occur. Concurrency control. The main aim of any database management system is to control requests for the same data at the same time from multiple users. Concurrency control algorithm try to coordinate the operation of concurrent transaction to prevent the interference among concurrently executing transaction in order to achieve transaction consistency. Types of concurrency control techniques. Lock-based concurrency control involves using lock to restrict access to data during transaction. Timestamp-based concurrency control assigns a unique timestamp to each transaction to determine their order of execution. Optimistic concurrency control assumes that conflicts are rare and validates transaction only at the end to detect any conflicts. Concurrency control protocol are divided into two types. One is log-based protocol. In log-based protocol, it is divided into two types. One is share log, second one is exclusive log. And second one is timestamp based protocol. It is divided into three types. Basic timestamp ordering, strict timestamp ordering, Thomas Wright rule. Log-based concurrency control. Two common types of logs are shared logs. It is also called read-only access and exclusive logs. It is also called as write access. Log exhalation is a strategy where multiple fine-grained logs are converted into a single coarse-grained log. Deadlock can occur when two transactions are waiting for each other to release logs, leading to a standstill. Timestamp-based concurrency control. Each transaction is assigned a unique timestamp representing its start time. Older transactions have priority over newer transactions to prevent the conflicts. Timestamp ordering ensures that transactions are executed in a consistent and predictable order. Optimistic concurrency control. Transactions are allowed to proceed without acquiring locks. At the end of the transaction, conflicts are detected and resolved. Rollback and retry mechanisms are used to ensure data consistency. Multi-version concurrency control maintains multiple version of data to allow for read consistency. Writer do not block reader and reader do not block writers. Each transaction sees a consistent snapshot of the database at the start of the transaction. Concurrency control in distributed database. Distributed database face additional challenges such as network latency and communication failure. Two-phase commit protocol ensures that all nodes agree on a transaction before it is committed. Distributed concurrency control algorithm coordinates transaction across multiple nodes. Challenges and trade-offs in concurrency control. Overhead in managing logs and timestamp can impact system performance. Striking a balance between isolation levels and concurrency can be challenging. Choosing the right concurrency control techniques depend on factors such as workload characteristic and system requirements. Best practices for concurrency control. Use the appropriate isolation level for your application requirements. Monitor and tune the database system to optimize concurrency control performance. Regularly review and update concurrency control strategies to adapt to changing workload patterns. Conclusion. Concurrency control plays a vital role in ensuring data consistency and transaction correctness in databases. Understanding the different concurrency control techniques and their trade-off is essential for designing efficient database system. By implementing effective concurrency control strategies, organization can improve system performance and maintain data integrity. Purpose of concurrency control to enforce isolation through mutual exclusion among conflicting transactions. To present database consistency through consistency preserving execution of transactions. To resolve read write and write conflicts. Example, in concurrent execution environment, if T1 conflict with T2 over a data item A, then the existing concurrency control decides if T1 or T2 should get the A and if the other transaction is rolled back or waits. Thank you.